Okay, so let's look at the last question we have to do on this first page with no proofs required. Question 6. And I think whatever time I lost doing question 7, I'm getting it back doing question 6. It turned out to be very quick. So you have a situation with a big circle and 4 little circles inside it, and you want to find the shaded area. And you know that the big circle is twice the radius of these medium circles. So exactly 2 of them fit in there. It's kind of like a basketball, I guess, basketball ring. And then if you want to find the area, then it suffices to find the radius of the small circle, because then the area would be then you know the areas of all the little circles, and you subtract it from the area of the big circle. So you know the radiuses of the big circle and the medium circles, but you don't know the radius of the small circle. So my working is like here. So I drew the diagram. So actually, if you connect the centers of all the circles, okay. So what do you know? Well, so you know that the centers line passes through the point of contact, okay? So each of these so the quadrilateral, you get the sides are all equal because they're the radii plus this radii. It's this radii plus this radii. Okay, so it's a rhombus. And a rhombus has the diagonals intersect at right angles. And you can sort of see by the symmetry these two centers are going to be joined by a diameter which is going to be halfway between these circles and going to be tangent to it anyway. But yeah, so if you know that, then you can get a right angle triangle here. Okay, and if I'll let the unknown radius be x, and I'll let the known medium radius be r. And this right angle triangle has, this side is little r plus little x, and this side is the radius. Okay, so you might have to show a little bit more that the center of the circle is actually also the center of the intersection of the diagonals. But you know that the diagonals bisect each other, so you know that this length and this length are going to be the same. And then they're the same when they're equal to the radius, right? So you know it actually passes through the center. On the other hand, this other diagonal is just the big diameter minus the little radius here. Okay. So if you know that this has to pass through the center, then these are going to be radial lines to the other center of the circle. So, I mean, the whole thing, this whole radius here is 2r but it was given in the question, and so this part is going to be 2r minus x. Okay, so you have by Pythagoras, r squared plus 2r minus x squared equals r plus x all squared. And then you could play around with this however you like. For example, I put the square on the other side and did a difference of 2 squares, cancelled out some stuff, and got x is equal to 4r over 6. Okay, and then the answer asks for the area, right? So you subtract. So that's the big circle area, pi r squared minus 2 pi r squareds of the medium and 2 pi r squareds of the small. Yeah, and I actually made a mistake. I didn't write the 2 the first time, so that was like quite annoying. And So without the 2 I got 475, and then when I added the 2 back in, I got 250. Okay, so that was a good quick question to get you back on track. So I think the first page now, we're on track to have probably finished that in exam conditions in like less than 2 hours, maybe less than 1 hour or 1 hour and a half if you're maybe in exam mode, but definitely less than 2 hours.